Okay, let's determine the x and y components of this vector. This is the vector of force. I know that because it is measured in newtons. So this vector is 12 newtons long. Now let's define its x and y components, but to do that we need first to find them on a picture and identify them. My x component would be the length from 0 to here, and y component would be the length from 0 to this point. This blue arrow represents my y component of the vector, and this one represents the x component of the vector. Here are the standard representations of x and y components. I'm using the capital F letter because I know that I'm talking about force, and subletters y and x identify whether I'm talking about x or y component of this force. My task is to find the lengths of these two blue vectors. To do that, I need first to remember the basic definition of cosine and sine. But let's start with cosine. Cosine is a ratio of the side adjacent to the given angle to the hypotenuse. So practically, I can rewrite it like this. Cosine of this angle 60 will be the ratio between the adjacent side of this right triangle to hypotenuse. Thus, I can calculate my x component as the product of cosine of 60, cosine of the angle 60 times 12, which equals 6 newtons. Now, since we successfully calculated our x component of the vector, let's calculate y component of the vector. To do that, we need to remember the basic definition of the sine. Sine is a ratio of the side opposite to the given angle to hypotenuse. So basically, I can say that the sine of this angle of 60 equals the opposite side to the hypotenuse. Considering that this opposite side is equal to my y component, I might as well put my y component over here in the numerator. Now, I can calculate the length of my y component by finding the product between the sine of 60 degrees times 12, which equals 10.4 newtons. Now, we have found x and y components of the vector.